Hello everyone, hope you're all well. Here we have an O-level trigonometry question that I would like to go through. And so let's jump right in. Here we see that ABCD represents four corners of a park, and AB is 70 meters, BC 80 meters, and CD 120 meters. And then they tell us the angle CAD is 50 degrees, and angle ABC is 120 degrees. And straight away they ask us to calculate AC. And so let's just highlight AC and let's take a look. Okay, how do we find AC? I think it's easiest to look at it this way. AC is part of this triangle ABC, and this triangle, you can see that we have two sides and the angle in between. And so that's actually really convenient because it allows us to apply the cosine rule. What is the cosine rule? Let me just write it here quickly. Cosine rule tells us that for a triangle ABC with the sides like this, that it tells us that a square, which is a being a length, this is a length, and it equals to b square plus c square minus 2 times b times c times the cosine of the angle in between, and let's call this cosine BAC. So let's look at that again. It really is a square equals to b square plus c square minus 2 times this length times the cosine of the angle in between those two lengths. Yeah. And when we apply this, what we can see, right? Let me just keep both in the picture. Yeah, what we can see is that this length, which is now, this is my a square, equals to this length b square plus c square minus 2 times b times c times cosine the angle in between. So let's write that down. AC square equals to 70 square plus a square minus 2 times 70 times 80 times cosine the angle in between. And actually you can key all of this on the right hand side into your calculator, and then you will see the AC square will equal to 16900. And do we want AC square? No, we needed AC. So let's just take a square root of this. And that gives us 130. So I'll just zoom out here for you to take a look at it and just digest it. Alright, now let's move on to the next part. Calculate angle ADC. So let's go back here. Calculate angle ADC. So let's just mark it over here where we want this angle that we're looking for. And actually from part A, we've already calculated that this is actually 130 meters. So now we can see that we are trying to find this angle, but we know the opposite side. We also know this angle and its opposite side. So this allows us to use the cosine rule. So this question really is just a straightforward application of all the rules. Part A was cosine rule. Part B is sine rule. And so let me just recap very quickly. Sine rule tells us for a triangle ABC with the relevant sides, and it tells us that sine this angle, sine A, let's call this angle capital A, over A equals to sine B over B, which is also equals to sine C over C. Yeah. So that's a very, very convenient rule, because it allows us to see that if I know the angle and opposite side, right, this is like sine C over small c, or like sine B over small b, or sine A over small a, I can actually create a relationship between all of them. So let's just see how it's applied here. In this case, we can see that, yeah, I can say sine this angle ADC over 130 equals to sine 50 over 120. So I'll write it down, I think it'll be clearer. You can see, I can say sine of ADC over, what is the opposite length of from ADC? 130. So you go for the opposite one, equals to sine, and then do we know another angle and its opposite length? Yes, sine 50 over 120. So let's do that. Sine 50 over 120. This is degrees. There we go. Now we can just evaluate this. So sine ADC is equal to 130 multiplied by sine 50 over 120, and that gives us angle ADC equals to 56.1. 56.1. So I'll just zoom out for you to take a look. Okay, now let's move to the last part. Calculate the area of the park. So we want the area of this entire park. One key thing to note is that this whole thing is made up of two triangles. You can ask yourself, do I know a formula that allows me to calculate the area of like this whole thing? It's not a square, it's not a rhombus, it's not anything that I know. All the sides seem to be different, the angles all seem to be different. I don't know any formula, but I know it's made up of two triangles, that much is clear. Can I find the area of a triangle? Area of a triangle, there are two ways. One way that we know is half times base times height. Well, in this case, we're going to use the second formula, which is for area of triangle, which is half times A, B, and sine C, where C is the angle in between. So let's look at this again. It's back to this same triangle. So half times A, so pick one side, times B, the side right next to it, any side, times the sine of the angle in between, sine C. So half times one side times the other side times sine of the angle in between. It must be the angle in between. It cannot be this angle and it cannot be this angle because those are not in between A and B. Yep. So in this case, we can see over here, of course we calculated this part from previously. So for this triangle, do we know two sides and the angle in between? Well, we know these two sides. If we can find this angle, then we have two sides and the angle in between. Yeah, that's great. Can we find this angle? We can. This angle simply because we know that the sum of all the angles in the triangle is 180, so we can do this. And that simply gives us 73.9. So I'm going to write that down. Okay, and then so we can find the equation. We can find the area of this triangle. So let's just go ahead and write that down. So half. Oops, let me use black. half times 130 times 120. So 130 times 120 times sine of the angle in between, which is 73.9, times sine 73.9. So there's one triangle. We want the other triangle as well. So now we want one side, the other side, and the angle in between. There we have it. We can say half times 70 times 80 times sine 120. So let's go there and say this is half times 70 times 80 times sine of the angle in between, which is 120. Yep. Let me just zoom out and you can just really take a look at how the formula is applied. You can pause at this frame and just look at it, right? Just applying area of triangle, this formula. All right, and so yep, once you key everything to the calculator, you will see that the answer is 9918.949, and it just goes on. And so really we can round it off to just 3 SF, the O-level way. There we go, 9920. So I'll zoom out now and you can just take a look at the whole question.